This is our derivative day 3, the power rule. Now, you would probably love this lesson because it's showing you easy way to derive functions. Instead of going through the long limit definition, we will find quicker ways. Now, for example, if I have f of x equals x squared plus 5x minus 3, I know some of y'all have noticed already that the first thing is the power. The power that you see here, I put a 1 here because the leading coefficient is 1. The power here, which is the 2, we multiply the leading coefficient to give us this 2. Now, the power of x, and note that the power of the x squared dropped to 1. So it moved from x squared to x to the power of 1. So does this one. The power of this x is 1. The 1 will move to the front, multiply the 5 to give me a 5, and the power of x will drop, giving me actually x to the power of 0, which is on just 1. So it's not needed here. So on g of x, I will have g of x equals 4x cubed plus 5x squared minus 3x plus 7. The 3 will move to the front, multiply the 4 to give us our 12. The power 3 will drop by 1 to give us x squared. Same thing on 5x squared. The 2 moves to the front, multiply the 5 to give us the 10. The power of x squared drop by 1. The negative 3x, the x will move, the power 1 will move to the front, multiply by negative 3 to give us negative 3. The x's would be dropped completely because it gets to the power of 0. Now, the derivative of a constant is nothing. So if I try to say, let's say h of x is equal to 5. H prime of x is equal to 0. A way to call h prime, g prime, f prime, we usually say d of f over dx. That means the derivative of, let's say, a function, derivative of f of x, derivative of a function that respect to x. This is nothing other than f prime of x, this being f. What exactly is the power rule? The power rule says the derivative of x to the power of n that respect to x is actually n times x to the power of n minus 1. This is a must know. If you know this, it makes your life easier. If c is the constant, I guess I got a little excited. I'm taking you back to this. If c is a constant, you will say the derivative of a constant that respect to x is always 0. Always. So here's the next one. The derivative of sine of x that respect to x is cosine of x. And the derivative of cosine of x that respect to x is the negative sine of x. Must know. That will make your life way easier if you know these by heart. Alright. Find each derivative. For the first one, to find that derivative, the first thing I would do is apply my power rule. Negative 4, the 4 will move to the front to give me negative 16x to the power of 3 plus 7 times 3 is 21. 21x, this was cubed, so this turns into a 2. 2 moves to the front, negative 4. That will just be with an x minus 10 plus 0 because the derivative of 9 will be 0, and that will be f prime of x. What is the slope of f of x at x equal 1? All I have to do is plug in 1. And if you plug in 1 into the equation, you will get f prime of 1 is equal to negative 16 plus 21 minus 4 minus 10. And your answer is negative 9. Alright, for 2 it says 5x cubed plus 3x minus 7 over x squared. One thing you can do is, because you don't know the quotient rule, you can instead transform this one as 5x, because I'm doing 5x cubed over x squared plus 3x to the power of negative 1, because I say this is for the power of 1. 1 minus 2 is negative 1, minus 7x to the power of negative 2. I just wrote it back down using omitting the fraction. Now let's apply the power rule. The power rule will give me g prime of x is equal to 5 plus, instead of plus, I would say plus -1 times 3 to the power x to the power of x minus 1. It turns into x to -2 because it's -1 minus 1. Minus 7 times -2 x to the power of -2 minus 1, which is actually -3. So all I gotta write here is -3. I can rearrange this one to say this is equal to 5 minus 3x to the power of -2, the plus 14x to the power of -3, which is equal to, if you want to make it fancy or slightly fancy, you can still say 5 minus 3 over x squared plus 14 over x cubed. And in case you want to write it with a common denominator, you will say it will be 5x cubed minus 3x plus 14 over x cubed. And I think this is the fanciest answer. All right, we got one more on this page, and that'll be f of x is equal to pi sine of x plus 3 cosine of x. Well, the derivative of sine of x, let's say f prime of x, is equal to the derivative of sine of x is cosine of x. So I will say pi cosine of x. The derivative of cosine of x is negative sine of x, is -3 sine of x. And this, I can put that in parentheses because I have double sign. So this is equal to pi cosine x minus 3 sine x. And that's, of course, f prime of x. And that's it. All right, number 4 says 5 square root of x over 2x squared. So I can rewrite this one as 5x to the power of 1/2 over 2x, or let's say 4x squared. Now I can combine these two to say it's 5 over 2 x to the power of -3 over 2. So once I'm ready to derive this function, I will say it's 5 over 2 x to the power of, before the x, I need to multiply by the power, which is 5 over 2 times -3 over 2, x to the power of -3 over 2 minus 1, which is -5 over 2, which is equal to -15 over 4, x to the power of -5 over 2. Now you can leave it as this, or it's better to have no negative exponent. So this is -15 over 4x, I can say 4 square root of x to the power of 5, and this will be the best answer. Number 5 says f of x is equal to 1 over x minus 4 cubic root of x. I will rewrite this one as x to the power of -1 minus 4x to the power of 1/3. So f prime of x in this case will be equal to -1x to the power of -2 minus 4/3 x to the power of -2/3. The way I'm finding this exponent is just by subtracting 1 from the original one, which is equal to -1 over x squared minus 4 over, this is minus 4 over 3 stays on the bottom. I can say it's the square root of, or like the cubic root, because 3 is on the bottom, cubic root of 2, or I should say x. And this will be our best answer. On problem number 7, I have 3x squared minus 6x to the power of -3 minus 5 over 2 cosine x plus the 5th root of x cubed. I will first transform this one into x to the power of 3 over 5 to make it easier for me. So this it's gone. Now I will use my power rule here. The 2 moves to the front, giving me 6x. Of course, I'm looking for p prime of x. That'll be 6x. Instead of minus, the negative 3 will multiply with the negative 6 to give me a positive 18 x to the power of negative 4 plus 5 over 2. Well, the derivative of cosine of x is sine of x, so it stays plus, and that'll be sine of x. And it will be plus 3 over 5 x to the power of 3 over 5 minus 1, which is negative 2/5. And that'll be your p prime of x. Let's find h prime of x now. H prime of x is equal to, I will use the power rule, but this time I have double function. So one thing I can do is I can first expand it. To expand it, you have 5 times. That'll be 4x squared plus 4x plus 1. Which is, once you expand it even more or distribute the 5, you will get 20x squared plus 20x plus 5. Now h prime of x will be now 40x plus 20. Number 9, which is probably the last one, says find the equation of the tangent line to the graph of f of x equals this. Well, the equation of in order for you to find the equation of a tangent line, you need to find f prime of x first. So, and we will evaluate x prime of x at x equal 2 to find the slope, and we write the point slope formula. F prime of x is equal to 6x minus 2. Once I find this, I find f prime of 2. F prime of 2 will be 6 times 2 minus 2, which is equal to 10. And this represents my slope, so this is actually my m. From here, I will go ahead and find f of 2, because I need y2 minus y1. That's f of 2 equals, I plug in 2 into this equation. That'll be 3 times 2 squared minus 2 times 2 plus 1, which is equal to 9. So at x equal 2 is actually the point 2 comma 9. So I can write the equation as y minus 9 is equal to m, which is 10x minus 2. Again, you do not have to go any further. This is good enough.